This is example 1. I'll just read it to you. It says, the ground of a subdivision lot slopes upward from the street at an angle of 8 degrees. So over here is the street, and from the street the ground slopes up at an angle of 8 degrees. It says the builder wants to build a house on a level lot that is 60 feet deep. So we want to come back 60 feet, and we want this ground to be level. Right now it's not level, right? It inclines up at 8 degrees. It says to control erosion, the back of the lot must be cut to a slope of 25 degrees. And so from the point where the lot is no longer level, we need to cut this at a slope of 25 degrees. Okay, and that's going to help with the erosion. How far from the street measured along the present slope will the excavation extend? And so they're asking us, how far from the street along the present slope will the excavation end? So in other words, all of this ground has to be removed so that we have a lot that is level, 60 feet deep, and then a back slope up to the hillside of 25 degrees. And so we're looking for the length of this side here. And so let's call this angle A. Let's call this angle B. It doesn't matter really what we call them. And we'll call this angle C. The side opposite here is side C. And the side opposite of angle B is side B, and the side opposite of angle A is side A. And so we're trying to solve this triangle. We know one of the angles is 8 degrees. Don't make the mistake of thinking that this angle is 25 degrees, right? That's this angle here. And so this angle is its complement, meaning that they add up to 180 degrees. So we'll have to take 180 minus 25, which is going to be 155. So the inside angle here is 155 degrees. And so what we know is 2 of the angles and 1 of the sides. Anytime we know 2 of the angles, we automatically can figure out the third, right? Because they all 3 have to add up to 180. And so let's do that first. The 3 angles A plus B plus C have to add up to 180 degrees. Angle A is 8 degrees. Angle B we don't know, and angle C is 155. These should add up to 180 degrees, and so angle B will be 180 minus 155 minus 8. And so we'll type that into the calculator. We have 180 minus 155 minus 8, and we get 17. So angle B must be 17 degrees. Okay, and so this would be 17 degrees. Okay, and so now that we know all 3 angles, we know an angle and the side opposite. That means we can use the law of sines, right? If we know an angle and the side opposite of that angle, we can use the law of sines. And so the law of sines says that A over sine A is equal to B over sine B is equal to C over sine C. Now the side I'm looking for is C. So I want to try to use C over sine C if I can, because that's the side I'm looking for. And I know angle B and side B, so I want to use the equation B over sine B is equal to C over sine C. So B over sine B is equal to C over sine C. And so side B is 60 feet. The angle B is 17 degrees. Side C is what I'm looking for, and angle C is 155 degrees. Okay, we want to solve for C, so we'll multiply both sides by sine of 155. Okay, these cancel. We get C equals 60 times the sine of 155 divided by the sine of 17. We'll type this in and we'll get our answer. So we have 60 times the sine of 155, close parentheses, divided by the sine of 17. And we get 86.73, 86.73 feet. Okay, and so this will be helpful to the excavator. Before any ground is removed, he can lay out a tape measure from the street up the current slope to some point, put a flag there, and he knows that that's how far back he's going to need to be digging. And so he can start removing some material until he gets back 60 feet. He'll have his flag up here, and he'll just connect the dots and remove the rest of the material. So the answer is 86.73 feet from the street to the end of the excavation. This is example 2. It says the Sanchez family wants a northern skylight built into the roof line of their house as shown in the figure, and I've drawn it here. The windows for the skylight are to be 4 meters long and make an angle of 40 degrees with the horizontal. And so they want us to find two things. How long must the rafters be on the south side? That's the length of this side of the triangle. And also, what angle does the roof make with the horizontal on the south? And so they're looking for this angle. So this is the south side, this is the north. This is the skylight window. It's 4 meters long and it makes an angle of 40 degrees. And so the roof line is asymmetrical. How long does this rafter have to be, and what angle does the rafter make with the roof line? And so when you look at the triangle, we don't know any angle and the opposite side, right? We know a side here, but we don't know the angle. We know a side here, but we don't know the opposite angle. We know an angle, but we don't know the opposite side. That's a dead giveaway that we need to use the law of cosines. And so we want to look for the most convenient variable to solve for here. The most convenient variable is going to be the side opposite the angle that we know. And so we want to use the form of the law of cosines that says that b squared is equal to a squared plus c squared minus 2ac times the cosine of b. And so again, if you remember, if it says b squared equals, it'll be the cosine of b. The other two sides are being squared, and we're minusing 2 times those two sides, right? Those same two sides. And so a little bit of practice, you'll remember the law of cosines pretty easily. And so we're looking for b. A is 4 meters. The figure in the book tells us that side C is 10 meters. In other words, the house is 10 meters wide. Minus 2 times A, which is 4, times C, which is 10, times the cosine of B, which is 40 degrees. Okay, so if we work all of this out, we will get b squared. Take the square root of both sides, we'll know b. And so we'll probably want to take this one step at a time. 4 squared is 16. 10 squared is 100. And we're minusing 2 times 4 times 10. So 2 times 4 is 8, times 10 is 80, times the cosine of 40 degrees. Okay, and so 16 plus 100 is 116. And we're subtracting 80 times the cosine of 40 degrees. I'll need my calculator for that. So 80 times the cosine of 40 degrees, close parentheses, we get 61.28. 61.28. And so now we can subtract 116 minus 61, 0.28, and we get 54.72. Last step now is take the square root of both sides. Cancels the square on the left. And so b will be the square root of 54.72. And we get 7.40. 7.40. And that's in meters. And so the length of the rafters on the opposite side need to be 7.40 meters. And the problem also asked us for this angle. And so now that we know an angle and a side opposite the angle, we can use the law of sines. And so b over sine b, because that's the information that I know. Right, I know that side and I know its opposite angle. So b over sine b will be equal to, and I'm looking for angle A, so I want to use 4 over sine A. Okay, or maybe I should write this, go ahead and write this as A over sine A for now. And then I'll plug in the numbers, right? So I know B and its angle. I'm looking for angle A, but I know its opposite side, so this is the form of the law of sines that I'm using. B is 7.4. Angle B is 40 degrees. And this will be equal to A, which is 4 meters, divided by the sine of A, which is the angle that I'm looking for. And so we will cross multiply and divide. We will get sine of A is equal to 4 times the sine of 40 divided by 7.4. And so we'll work this out on the calculator. We have 4 times the sine of 40, close parentheses, divided by 7.4, and we get 0.347, maybe one more, 5, 0.3475. Now we'll take the inverse sine of both sides. Okay, and A will be equal to the inverse sine of 0.3475, and we get 20.33 degrees. 20.33 degrees. The picture really helps to help you visualize if you have the correct answers or not. If I had an answer like 60 degrees, that wouldn't really fit the picture that I've drawn. So this may not be exactly 40 degrees, but it's close. The ratio may not be exactly 10 to 4, but it's close. And so if my answer was way off, I would have had a good idea of that just by looking at the picture.